Okay, so we're going to be talking about creating equations today, and this is something that we've been reviewing a lot for the past couple days. So today we're going to talk about it in an application. We're going to talk about it as an application. So the first thing I wanted to do is review some basic concepts of creating equations. So first I want to ask, what is a slope? Yes.
Slope is rise over run.
Good. Rise over run. Okay? So a steeper slope is when there's more rise over less run. So there's a steep slope. We also have positive slopes and negative slopes that go down this way. Positive and negative slopes. What is the y-intercept, Elizabeth?
Where the line crosses the y-axis.
Good. So the y-intercept is where the line crosses the y-axis. And we've learned an equation that's really helpful for this, and it's y equals mx plus b. Where the b is the y-intercept, which can be any number including 0. It's just anywhere it crosses the y-axis. And the slope is represented by the letter m, and it can be positive or negative. So that's just a little review about creating equations. Now we're going to talk about our application. So we're going to apply equations to density today, which you've learned about in your science classes. So I have a question to throw out there really quickly. Which is more dense? A bowling ball filled with air, a beach ball filled with air, or a bowling ball where they are both the same size and volume? Yes.
A bowling ball.
A bowling ball. A bowling ball is more dense. How come?
Because there's more mass.
Yeah, there's more mass and a smaller amount of space. More mass. Where air is very light. So here we're going to talk about our plot that has mass versus volume. So mass is going to be anything on the y-axis. Volume is going to be on the x-axis. And like was mentioned before, slope is rise over run. So here, slope is mass over volume, which is what density is. Density is how much stuff we have in a certain amount of space. Okay? So we're going to try this right now. We're going to do an application where you plot the mass versus the volume to try and find the density of some objects of different sizes. Some helpful hints are that volume is base times width times height for rectangular objects. So now we're going to go ahead and do the lab. And for this part, I'm going to be a student. Okay, so let's go ahead and take the mass for these. I'm going to write that down. Okay.
By 10, so 90, 87 about there.
Okay. We know that, let's see, well that one's not quite with the other two. We should say, maybe it's not made out of the same material.
Yeah.
Let's do it with these two. Maybe it's made out of something different. Okay, so now I'm going to be the teacher again. I'm just going to ask some questions about how the lab is going so that I can see what we understand so far about density. Okay, so it looks like so far you've made a pretty good representation of the density for these two because we have a linear relationship. I'll just show this. So here we've got the linear relationship. We can see mass versus volume. So now you have this object, which we don't know if it's the same as one of these. So how could you tell if it's the same as one of those? What would the process be that you would go through?
Well, I could weigh it.
Yeah, you could do the math. Let's see how heavy this object is.
It stays.
Surprisingly. Yeah. So it's really heavy compared to the other ones.
I forgot to put that down.
So how does this compare to your other objects, mass-wise? Does that have a
it's
pretty heavy mass compared to
Yeah,
how big it
it's
is?
a lot bigger.
So it's not a huge object, but it's a heavy mass. So maybe we'll have to see if it's the same density or not.
Okay, so this one is about right there. So this one is 320.5.
Okay, so pretty heavy.
pounds.
Do you know how you would find the volume for this object?
Using this equation.
Right, using the equation for a sphere, right?
Okay.
So it's going to have a different volume. Let's go ahead and find out what its volume is.
So 4/3 pi r, just kind of 2.
Yeah, 2 looks about right. It's for your radius.
Okay. So 4/3 pi, 5/3 pi, and 2 squared.
16. So how does that volume compare to?
The volume's a lot smaller.
A lot smaller than your other objects, even though and its mass is much bigger than the other ones.
So it seems like it's a little off.
Yeah, so let's see if the density is the same.
So should we graph it?
Yeah, let's do it.
Okay. So we go to 16 here, 5, 10, 15, and then 3. I guess that is still on our graph. 320.
Okay, so what does that tell you about the object?
It's not the same material.
It's not the same material. Is it more dense or is it less dense? What do you think?
More dense.
More dense, how come?
Well, your example earlier about the bowling ball,
Mm-hmm.
that it's a lot more mass in a smaller object.
Right, in a smaller area or a smaller volume. And it makes sense. So here you have this linear line that shows you that these objects match up. The more mass we have, the more volume we have. So same density as before.
Okay.
But here we've got a really small volume and we have way more mass. So obviously doesn't fit our equation that we've made for our objects.
Okay.
Okay, great.
Okay.
Nice job. Okay, so now I think we should have a class discussion about how this application relates to creating equations. So we're going to just talk about a couple of questions here. So here you have your two objects, and as you can see, as we had more mass for one, we had more volume for the other one. So they're the same density, right? The same amount of mass and the same amount of space. And then we had this object 3, which was our sphere.
Yeah.
That really stood out, right? We had a huge mass, huge volume. So this obviously isn't the same density because it doesn't fit our line.
Right.
But let's talk about some other things about our line. What does this y-intercept mean? Is 0. What does it mean to have a 0 y-intercept here? Any ideas?
Well, if it meets at 0, then it means that there's 0 mass and 0 volume, so 0 density.
Yeah, so when there's no mass and no volume, we can't have any density.
Because
There's
no object.
nothing, there's no object. So this says that no mass and no volume is equal to no density. So we can't have density without both of those things. Okay? So we can't have that without both of these things. What does it mean? So I'm going to draw a couple of slopes up here and let's compare their densities. So I'll just draw this. So I'm going to draw this slope. And we're going to have an object here and here. And then I'm also going to draw the slope for object 3. Okay? There's some other objects that have the same density. Okay, so what can you tell me about the difference? What difference the slope between this and this tells us about the objects? So what does this slope that isn't as steep say about these objects that's different from these objects? Any ideas?
Well, objects 1 and 2, you were saying when it's steeper, it rises faster than it runs.
Uh-huh.
So the mass is larger than the volume.
Right, so that goes back to the other thing we're talking about, rise over run. So in this case, which is mass over volume, so in this case, we have a bigger rise or a really big mass over a little volume. And what does a big number divided by a smaller number tell us? What does it give us?
Something bigger than
Something big, yeah. So this is also going to give us a big density. What about this one here? Do we have a big mass and a big volume, or?
No, it looks like we have a small mass and a big volume.
Yeah, we have a small mass and a big volume. So what does that tell us about the density?
We're really small density.
Small density. So isn't it interesting that we can talk about what things mean in real life using the equations that we worked on? Let's look at object 3 for a second. What's the difference between object 3 and object 2?
That one has a huge mass compared to the other one.
Huge mass, right? So we have a huge mass over a little volume, which gives us
huge density.
Huge density. Okay, so as we can see, we have small density, a bigger density, and an even bigger density the steeper our line goes. So where would the beach ball be on here? Going back to what we talked about before.
This one.
This one right here. Yeah, because we have a really big volume, but it's full of air. So it's not very massive. And our bowling ball could be this object or this object. Does that make sense? Yeah. So quick recap. Y-intercept tells us no mass, no volume, no density. A steeper slope gives us a bigger density than before because we have
more mass
over a smaller amount of volume. Exactly. All right, so there's our application for creating equations.